Today, let's talk about event-driven architectures. Modern applications today need to present the task quickly and support media user. For traditional applications that use request and response communication, it's not enough for this requirement. In this video, I will talk about what is an event, what is event-driven architectures, how many core components of developing event-driven architectures, the benefit and challenge of event-driven architectures, and the last one in real-world example. What is an event? Event is simply something significant that happens in system. So when user do actions, it will generate event. For example, in e-commerce platform, when user places an orders, it will generate an event called order created. And then the service that generates events called event producer, and it will publish the events to event brokers, and any interested service that subscribe to the events reacts to the event independently. What is traditional architectures that do similar thing? In traditional architecture, user request to service A, service A request to service B, service B request to service C. So each service need to wait for another service. If one service becomes slow, request of the user will be slow and everything will be slow. In contrast, event-driven architectures, user request to service A publish an event, so it doesn't need to wait for other parts of the system or the service to respond. So this make each system or this make each service loose couplings, scalable and flexible. How many core components of event-driven architectures? There are three components of event-driven architectures, such as event producers. Event producer is the service that generates events. As an example above, when the customers place an order, so order service is the event producer that publishes order created. And then any interested service that subscribe to the events will do some things in their local space. Event brokers. Event broker act as the middleman between event producer and event consumer. It receive the event from producer and then distribute the events to event consumers. And event broker is critical. If the event broker down, the communication between event consumers and event producer will disconnect. So it is critical to make sure that event broker is always running. So we need to design event broker to be broker cluster. In broker cluster, there are multiple brokers. Event consumer. Event consumer is the service that receive the event. For example, when producer produce order created event, and then event consumer such as notification service receive the order created event, and then they will send confirmation email, and payment service will receive the event, and then it will do payment processes. So events consumer does not need to know who produced the event. They just focus on event topic. This approach will make the service flexible, scalable, and reliable. What are the benefits of event-driven architectures? It is scalable. So when we want to increase the resource for a service, it doesn't affect another service. For example, if the notification service need to consume additional resource, we can increase the resource for specific notification service without affect another service because it's stand in different server. Loosely couplings. In event-driven architecture, it is loosely coupling because if there is something changed in other service, it does not affect another service. It is flexible. It means that when there's additional service, we can add more without changing another service. For example, if we want to add new consumers, so we don't need to change producer. We just config the consumer to subscribe to the topic that they need. What are the challenges of event-driven architectures? In event-driven architecture, even it have many benefits, but it also bring challenges such as complexity. So complexity, it means that we need to manage microservices, we need to config microservices to work together, especially to config event brokers. It can be data consistencies, so different bits may not update at exactly the same time. So this will be delays for the latest data between services. The concept is known as eventual consistency, because as you know that when we develop using event-driven architecture, we want to take availabilities over consistency, but we need to keep eventual consistency to make sure that data is synchronized across services. So let's talk about real-world example. Many large companies use events-driven architectures. For example, banking system. Banking system, when the money is transferred, account balance updated, fraud detections, check transaction, and notification sent. For e-commerce platform, when customer go to split orders, it will create order created event, and then inventory service will update stock quantities, payments will process payment, notifications will send email. In microservices, always need event-driven architectures. In conclusion, event-driven architectures enable systems to communicate using event rather than direct requests.